Today we are going to discuss Boyle's law, its graphical representation, its application in our daily life. We are also going to discuss a few numerical problems based on Boyle's law. Boyle's law gives the relationship between pressure and volume. If we want to establish relation between pressure and volume, we have to keep other two variables constant, that is temperature and number of moles. Boyle's law gives the relation between pressure and volume. This law was derived by Robert Boyle. Here, for the experiment, we took n number of moles of gas at constant temperature. Because we want to establish relation between pressure and volume at constant number of moles of gas and temperature. Here, T1 pressure is applied and the volume of the container is V1. When we compress this gas by increasing pressure on it, and now volume reduces to V2. When we reverse the process, we will get expansion. What you have observed in this experiment? You must have observed that gas in second container is denser. V1 is more than V2 and T1 is less than T2. Means on increasing the pressure, volume decreases. So there is inverse relationship between pressure and volume. Pressure is inversely proportional to volume, or you can say pressure is directly proportional to 1 over V. This relation is known as Boyle's law. That means when we double the pressure, volume of gas reduces to half. Now let's derive the formula for Boyle's law. According to Boyle's law, pressure is directly proportional to 1 over V. When we remove this proportionality sign, we will get a constant. So we will get equation pressure is equal to K is the constant multiplied by 1 over V, where K is a proportionality constant. Its value depends only on temperature. When we transfer this volume on the other side of the equation, you will get pressure multiplied by volume is equal to constant. When we apply the same formula for the initial state, we will get P1 multiplied by V1 is equal to constant. And now name this equation as equation 1. Now apply the same formula for the final state. So here you will get P2 multiplied by V2 is equal to constant. This is the equation 2. Now compare both the equations. On comparing, you can see right side of the equations are same. So the left side will also become equal. In that way, you will get P1 multiplied by V1 is equal to P2 multiplied by V2. So here you will get two formulas. Pressure multiplied by volume is equal to constant, and another formula P1 V1 is equal to P2 V2. These two formulas we are going to use to solve numerical problems based on Boyle's law. Now let's see how do we plot a graph for Boyle's law. We know pressure is equal to constant multiplied by 1 over volume. This formula we just have derived. We can also write this formula as P is equal to constant multiplied by 1 over V plus 0. We have the straight line equation y is equal to mx plus c. When you compare both the equation, you can see this equation also represents the straight line equation. Now compare Boyle's law equation with the straight line equation. On comparing, you can see pressure can be compared with y. K can be compared with m, that is the slope of curve. 1 over v can be compared with x, and 0 can be compared with c, that is the intercept. So we have plotted pressure on the y-axis and 1 over v on the x-axis. So we will get a straight line because this equation is of straight line equation. With the slope k and intercept is 0, that means it should originate from 0. Straight line shows direct relationship between pressure and 1 over volume. We just have derived the equation pressure is directly proportional to 1 over volume. Pressure and volume relation was established at constant number of moles and constant temperature. That's why this line is known as isotherm. Iso means same and therm means temperature, means the experiment was conducted at constant temperature. And this is the slope. This slope is equal to K and its value depends only on temperature. Now let's see what will happen if we conduct experiment under different temperature condition. When we perform the experiment at T1 temperature, we will get this yellow line. But if we perform the same experiment under different temperature, then what will happen? For different temperature, we will get different isotherm. Each isotherm has different slope. Since the value of K depends only on temperature, and temperature is directly proportional to slope. That means on increasing the temperature, the value of slope will also increase. That means if we increase the temperature from T1 to T2, slope of curve will also increase and you will get another straight line that originates from 0 with greater slope. If we further increase the temperature to T3, you will get another straight line that originates from 0 having greater slope as compared to T2. When we plot graph between pressure and volume, you will get a curve and this curve shows the inverse relation between pressure and volume. We just have derived the equation pressure is inversely proportional to volume. For different temperature, we will get different isotherm. For example, this experiment was done at T1 temperature and we have got this curve. On increasing the temperature, curve of isotherm decreases. So when we increase temperature from T1 to T2, you will get this curve, lesser slope than before. When we further increase the temperature to T3, slope of curve will further reduces and you will get this curve. Now let's see how density related to pressure. We have the equation PV is equal to K that we have derived for Boyle's law. And we know density is equal to mass over volume. So when we rearrange the equation and shift volume on the other side of the equation, we will get volume is equal to mass over density. Now place the value of volume in the equation 1. So you will get pressure multiplied by mass over density is equal to constant. Now transfer mass on the other side of the equation. So you will get P over density is equal to constant over mass. And you know, when we do any mathematical operation to a constant, it results in another constant. So here when constant K is divided by mass, we will get another constant that is K dash. So here you will get the formula pressure over volume is equal to constant. That means pressure is directly proportional to density. Now come to the applications of Boyle's law. What happens when we open a cap of soda bottle? You must have heard the fizz sound and with that sound bubbles comes out. When we loosen up the cap, pressure inside the bottle reduces and volume increases. That's why gas rush out from the bottle. How does a spray bottle work? When we press the nozzle, spray comes out. On pressing the nozzle, it releases the pressure. That means pressure reduces. And on reducing the pressure, volume increases, which causes molecules to come out forcefully. Breathing is another application of Boyle's law. During exhalation, diaphragm goes up and because of it, volume of lung reduces. As the volume reduces, pressure inside the lung increases. And as you know, air moves from high pressure to low pressure. Inside the lung, pressure is high. And outside the lungs, pressure is low. So that's why air moves from in to out and we are able to exhale. During the time of inhalation, diaphragm goes down and because of it, volume of lung increases. As the volume of lung increases, pressure inside the lung decreases. Now, pressure inside the lung is less than the pressure outside the lung and air moves from higher pressure to lower pressure and that's why we are able to inhale oxygen. Now let's practice a few examples based on Boyle's law. For a given mass of a gas at constant temperature, if the volume V becomes 4 times, the pressure P will become, and these are the options. So let's try to solve this question. We know pressure is directly proportional to 1 over volume. So if we increase volume by 4 times, pressure will be decreased by 4 times. So option C will be the right option for this question. Come to the next question. At constant temperature, the pressure of Vml of dry gas was increased from 1 atmosphere to 3 atmosphere. The new volume will be, and these are the options. So initially what is given? P1 is given 1 atmosphere and V1 is given Vml. And in final state, P2 is become 3 atmosphere and here we have to calculate V2. So let's apply the formula P1 V1 is equal to P2 V2. Now place the values in this formula. P1 is given 1 atmosphere, V1 is given Vml, P2 is given 3 atmosphere and V2 we have to calculate. Now transfer 3 atmosphere to the other side of the equation. We will get 1 atmosphere multiplied by Vml divided by 3 atmosphere is equal to V2. Atmosphere and atmosphere will get cancelled out and you will get V2 will be equal to V by 3 ml. So the option C will be the right option for this question. Now come to the next question. A balloon is filled with hydrogen gas at room temperature. It will burst if pressure exceeds to 0.2 bar. If at 1 bar pressure, the gas occupies 2.27 liter volume. Up to what volume can the balloon be expanded? Let's try to solve this question. Here is the initial state of the balloon and this is the final state of the balloon. At the initial state, P1 is given 1 bar, P2 is given 0.2 bar, V1 was given 2.27 liter and here we have to calculate V2. Now apply the formula P1 V1 is equal to P2 V2. Now place the value in the given formula. P1 is given 1 bar multiplied by V1 that is 2.27 liter will be equal to P2 that is 0.2 bar and V2 we have to calculate. Now transfer 0.2 bar on the other side of the equation. So here you will get V2 will be equal to 1 bar multiplied by 2.27 liter divided by 0.2 bar. Here bar will get cancelled out with bar and on dividing 2.27 by 0.2 you will get 11.35 liter. This will be the V2 volume. So your answer will be volume should be less than 11.35 liters.